Hi there, on this screencast I'm going to solve the final exam review problems for college prep math. Alright, number one and two, and I think a few of them after, are simplifying exponential expressions. So I have the order listed here of the steps in simplification that I always follow through with. So the first thing I'm going to do is always change zero exponents to 1. So essentially you can cross them out. Um, and in this problem, that's really the only thing you can do. So the answer is just going to be 3x cubed y squared. So that one's pretty easy. All right, and number two, let's see, do I have any zero exponents? No. Do I have power of a power? Yes, I do. So power of a power means you have parentheses and you have an exponent outside the parentheses. So that's the next thing I always take care of. And essentially, you're going to distribute the exponent. So that's going to give me 3 cubed x cubed. And when you distribute, you multiply them together. Y to the negative 3. Okay, I don't have anything. Yes, I do have negative exponents. So that's the next thing I do. So um, 3 cubed x cubed, and the y negative 3 goes down in the denominator and becomes y positive 3. And the last thing to do is I would write 3 cubed as 27. So you would get 27x cubed over y cubed. Yes. All right, let's see what the next one is. Okay, so right off the bat, there aren't any zero exponents, but you can tell there's a 4 in the numerator and the denominator, so you can cross that right out. Then let's see, I'm going to move on. I don't have power of a power. I'm going to move on to negative exponents. So what's going to happen is every negative exponent in the denominator is going to go to the numerator, the base along with its exponent, and become positive. So the one u on top stays there, but the u negative 4v minus 4 in the denominator becomes u positive 4 v positive 4 in the numerator, and then this v negative 4 that's in the numerator goes down and becomes the denominator, into the denominator. And if everything, by the way, if everything changes and you're left with nothing, you write a 1. Okay, so the next step, I can see the v4 over v4 are going to cross out. Now I'm going to use the quotient rule, or the product rule, and that's when you have two bases that are the same, you add their exponents together when you simplify. So that's going to be u to the first plus u to the fourth. 1 plus 4 is 5. And that would be your answer. Okay, in this one, let's see, we have power of a power, so we can do that first. So it's going to give me 2x to the fourth, y to the fourth, x to the 16th. There aren't any negative exponents. I'm going to do the product rule to combine the x's. So I add those exponents together. I get 2x to the 20th, and then I can't do anything with y to the fourth. So that's just my solution. Okay, so 5 and 6 are getting a little more complicated. So let's see, I'm going to multiply 3, 4, and 4 together and get 48. And that'll make things look a little simpler. Then I'm going to handle negative exponents. So I have 48n squared, and that's all that is in the numerator. And then I have this m1 goes up into the numerator, and then this one, and that one go down into the denominator. So that's going to give me n squared m to the fourth n. Okay, so now I can see I have an n squared in the numerator and denominator, so I can get rid of that. And now I'm going to use the quotient rule. So you keep the base and for m and subtract the exponents. So 1 minus 4 is going to give me negative 3. So I'm going to have m negative 3 in the numerator. That's going to go back down to the denominator and become m positive 3. So I'm going to be left with that. Another way to think about the quotient rule is, okay, m to the fourth is really m, 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 m. M to the first is m. One of them is going to cross out, leaving you with three of them. So I usually think of it that way rather than thinking of the quotient rule in my head. Okay, this one, let's see. I'm going to get 16. I'm going to use the product rule. Well, actually, let me do the negative exponent rule first. So I'm going to get 16 u squared u to the fourth v squared v cubed, because that's going to go into the numerator. And then I'm going to get, let's see, so I end up with 4u cubed. So let me do the quotient or the product rule and combine bases in the numerator. So that's a little bit too big. Let's try 300%. That's better. So what do I have? I have 6 u's and I have 5 v's. So it's going to be 16 u to the sixth v to the fifth over 4 v cubed. And then I'm going to do, okay, I have 6 u's in the 5 v's in the numerator, 3 in the denominator. 3 of them cross out, leaving me with 16 u to the sixth v squared over 4. And 16 over 4 is just 4. So I get 4u cubed v squared. All right, so that would be my solution. Okay, this one, the zero exponent rule means that this whole thing becomes 1. So I have 1 over 4b, and then b4. And that a negative 1 is going to go in the numerator, become a to the positive 1. So I end up with a over, and b1, b4 is b5. And that's that one. Okay, now we're moving on to ones that have fractions. So the rules are the same, it's just you're going to be working with fractions instead as exponents. So I can see I have 3 times 3 is going to give me 9. And p to the 1/3 times p to the first. Okay, so I'm going to use the product rule because I have a repeated base beside itself. And I keep the base and add the exponents. So that means I need to do 1/3 plus 1. Adding fractions is where you need a common denominator. So I'm going to multiply that one by 3 over 3. So I end up with 1/3 plus 3/3. That's 4/3. So my simplified expression is going to be 9p to the 4/3. Okay, v to the 7/4, really nothing you can do with that one. Not sure why that qualified as a problem, but apparently my problem generating software thinks it does. Okay, so let's see, x over x to the negative 3/2. So I'm going to go right to the negative exponent rule, which also applies when you have fractions. And I'm going to get x over 3, and then that's going to be x to the 3/2. Now I'm going to use the product rule. And the product rule means I have to add those exponents. So this one's similar to the last problem. So I need halves. So 1, if you convert it into a fraction with a denominator of 2, you multiply by 2 over 2, you get 2 halves plus 3 halves. Well, that's 5 halves. So I'm going to end up with x to the 5/2 over 3. All right, this one looks a little more complicated. So I have parentheses, so I need to do power of a power. So I distribute the exponent in the numerator, and I get a to the 5/4 because I'm multiplying 1 times 5/4 is 5/4, and then that's a. So when I do power of a power, I multiply fractions. Multiply fractions, you go straight. You multiply the numerators and multiply the denominators. So I'm going to get -8. No, I'm sorry. What am I thinking? One step ahead of myself. I get -5/8, and that's all over a. Okay, so let me do, I'm going to move on and do the negative exponent rule. So that's going to bring the a to the -5/8 down into the denominator. So I would have a to the 5/4 over a times a to the 5/8. And now I want to combine a and a to the 5/8. And what does that give me? Well, I have to do 1 plus 5/8, which is 8/8, plus 5/8, which is 13/8. Ugh, not a, 8. Oh. Okay, so that gives me a to the 5/4 over a to the 13/8. And now I'm going to, let's see, use the quotient rule and do 5/4 minus 13/8. So 5/4 minus 13/8, I need a common denominator, and it's going to be 8. So I multiply that by 2 over 2. I get 10/8 minus 13/8. That's -3/8. 10 minus 13 is -3/8. So what happens there? I end up with 1 over a to the -3/8. And that is just a to the 3/8. So I do a to the 3/8. I use the negative exponent rule once again. And that goes up in the numerator, and you're left with a 1 in the denominator, so you don't even need to write it. All right, so that's the first part. Those are problems 1 through 11 dealing with the rules of exponents. I'm going to make end this screencast here, then start up a second one to do some of the equations related to this, and maybe the radicals as well. All right, cheers.